Welcome everybody to Speakeasy JS, the JavaScript meetup for mad science, hacking, and experiments. So I'm joined here today by an amazing panel. Everybody can say hello. Cool, and then we have our speaker, Suz Hinton, who we'll introduce in a moment. So the idea of Speakeasy JS is to be a meetup for mad science, and mad science is all about pursuing your interests and doing things for no other reason than because you can. So it's about following your curiosity, and the idea is to inspire people to do more of that in their lives if they're so inclined. And so today we have Suz Hinton with us, and where to start? So I guess Suz is a programmer and author, a Node.js mad scientist. She does hardware hacking, 3D printing, all kinds of crazy things. And we're also on the JS Party podcast together. So we'll also sometimes be on the same podcast there. And she's also currently, yeah.
Once a year we manage to kind of like schedule, yeah.
But it's theoretically possible that we'll be on the same podcast again. She also does developer relations at Stripe. And really, I honestly know Suz mostly through all of her educational content that she puts out. So she really helps people understand programming and does a lot of Twitch live streams and helps people sort of learn and inspire them to do creative projects. So it's the prototypical example of a mad scientist that we like to highlight here at Speakeasy. So I'm really excited that she's here. And we're also joined by our panelists, John Heisey and Paul Frazee. So really excited to have them here as well. Cool. So with that, I think that we'll let Suz take it away. It's all yours. Stage is all yours, Suz.
Great. Thank you. Everyone is being so nice in the chat already. I just wanted to say thank you for that. Also, it's been a week. So I just wanted to acknowledge that and just say, hopefully we can just nerd out for, the next half an hour or so. But it's been rough, and I just want to acknowledge that and say that hopefully we'll be out of the woods really soon. But yeah, thank you for coming. And again, let's have a little bit of joy and just kind of like put down the refreshing incessantly for a little bit of time. So today, again, thank you, Speakeasy, for having me. This is really cool. It is so nice to have such a nice intro from Faraz as well. I respect Faraz so much, and we've known each other for a couple of years now, mostly because we're both always just experimenting with stuff for seemingly no reason other than just curiosity. So I'm really excited to talk to you today about digital preservation. But when it comes to things like hardware tooling, which is something that I'm really passionate about, and I really want to make the user experience better, but I also want to ensure that as we sort of see obsolescence happening, more and more rapidly, that we try to take steps to avoid it before it's too late. So some of this stuff is some things that I've been talking about for a lot of years. If you've ever seen any of my talks before, some of this content will be familiar, but it's just sort of reframed to talk a little bit more on a personal level as to like why I care so much about trying to, express hardware tools, especially in the JavaScript ecosystem, right? Because I think that you can get some really powerful things out of it. So again, thank you for joining me, and let's get started. So I have not done a talk in quite a while, just because pandemic, but also been trying to take a break. So I just couldn't bear opening keynote. So we're doing this in Vim today. So just bear with me as well. It's just a bunch of Vim buffers, but we should actually be able to read it. So let me know if you need to be bigger or anything like that. And for us, feel free to interrupt me. Also, if there's any election news that's a big deal, feel free to interrupt me too, because that's actually pretty important. Okay, so what is digital preservation just in general? Let's talk about that like really quickly. So digital preservation essentially ensures that digital information that has like continuing value remains accessible and usable, right? So making sure that future generations can continue to enjoy the same digital assets that we were able to, right? And trying to make sure that they kind of stay the same, and that they, I guess, like for want of a better word, like their spirit or just like the vibe of the digital item stays the same too. So that it's, I guess, a good word for that is authentic, keeps its authenticity. So why do we even need to do this in the first place? Like computers have come a long way, and we've been able to open JPEG files for really long time now. Like, is it really that much of a problem? Well, the big issue is that computers and their standards change a lot, and sometimes quite quickly. And we'll go over a few examples of that today, just to show how fast that can change. Digital media, particularly like storage media, can actually be really fragile. And so we're talking about things like bitrot, or even just digital media having specific dependencies that it relies on that have disappeared. So it might not actually be the media itself. Environmental factors can be at play too. Things like moisture and temperature can really wreak havoc, again, on things that are stored, or just like computers and machinery and hardware themselves, right? There's also, something that we can probably identify with a little bit more, which is format obsolescence, which is just like, we just don't support certain file formats anymore, or we just don't really have any engineers or any people on the planet that actually like know anything about a specific format, and that knowledge dies, and then the format actually dies as well. And then also physical media obsolescence. So a pretty classic example of that is things like floppy disks, very impractical, very low storage. We just don't really use them anymore, right? So that's an example of physical media obsolescence that can cause digital preservation issues, particularly if there's files on them, right? So that's sort of like a whirlwind tour of like the context that we're talking about when it comes to digital preservation, but it can cover everything from things such as digital photos to music and audio. But I think more importantly, like what we're focusing on today are things like software applications and hardware tooling, right? So software applications are still something that we would want to preserve, right? Even though they're not necessarily like art or like, I guess, like seen as a cultural thing of importance, like on face value, but it is actually important to us as engineers. So digital obsolescence is just going to be a thing that continues to happen over and over again, and it's really going to depend on like how we move and progress computers forward, but also whether there are actually environmental factors that we're not thinking of right now that could also affect a lot of things as well. So like, what is actually being done about this? Are there groups that are already trying to solve it, and where do I fit into this? So strategies that we use right now in order to try to digitally preserve things are usually split into like different things depending on what that digital item actually needs, right? So the first one is refreshing, and that's essentially avoiding bitrot from physical media deterioration. So let's say we have a CD, and the CD has files on it, and we want to make sure that that CD doesn't deteriorate, because there are some CDs out there that can supposedly last for thousands of years, but they were expensive and they weren't super popular. So we have to be mindful of that. So refreshing is like usually strictly referring to just copying the data from one CD to the other, just in order to kind of make sure that we are refreshing all the, I guess, the bits before they end up, suffering from bit rot. And then we can just every, so much time that goes by, we can have a schedule where we just keep refreshing it, right? So it's not quite the same as replication, but it's very similar. We have migration next, which means that we take the digital asset and we port it to newer platforms. So an example of that could be something like, I don't know, like let's say there's an application that only runs, in a 32-bit context, right? And let's say that, there are certain operating systems that aren't going to support that going forward. We would migrate that so that it's compatible with 64-bit machines. So that's like a very kind of, I don't know, that's a very contrived, but very simple example, right? But there can be, other more complicated instances of that. Next up, we have replication, which is archiving many copies. So it's similar to refreshing, but what you're really doing is just making sure that, I guess, like we can talk about this in terms of distributed systems on the web, right? Like we make sure that geographically we've kind of have enough copies that, let's say if like a data center goes down, or there's like a fire in like, somewhere where you've got a hard drive, you still have like a copy somewhere else. So, I mean, that's pretty self-explanatory, but that's really what that's doing as far as digital preservation goes. Next up, we have emulation. So what we can do is, let's say that the digital asset still retains its authenticity with some layers kind of being replaced with like software equivalents, then we can use emulation to do that. So if it's replacing the hard layers that, again, like don't really affect how it's received, then that can be a really good option. And so that can be everything from emulating like floppy drives in order to like load certain files in a specific way so that a program can still run, so that it still thinks there's a floppy drive there. That can be kind of a low touch way of not actually changing the integrity, of the software that's actually already running. So that we're not actually like having to change the code, which we also might not even have access to. So we can use emulation on the side to solve that. Next, we have encapsulation. So this is the concept of taking a digital asset that might have dependencies on other things in order to like run, or in order to be viewed, or in order to work, and just making it more self-contained. So it's usually like wrapping it in like either extra layers of software or extra layers of metadata in order to make sure that it's not going to sort of have like dependency breakdowns in the future, like it did in the fashion where it's actually needing encapsulation in the first place. Sorry, I've just looked at the chat. Oh, cool. Someone's sharing readings. Thank you, Todd. That looks awesome. And then the last thing is metadata attachment. And metadata attachment is much more low touch. It's really just adding additional context. And usually that's in the form of ASCII files in order to preserve, like, let's say the history of a digital asset, and maybe like steps on how to get it running, or, to get it working properly again. And even just like who actually made it, and why, and just like things like that can like just basically, it's more about preserving context, and also giving the opportunity for restoration in the future. And so even just having that little bit of information, that little bit of documentation, like the missing manual for something, can be really helpful. So again, that's a really low touch way to document something, especially if you don't have the resources to do some of the other things such as encapsulation, or emulation, for example. All right, so let's talk about archiving as well, because that's something that's like really huge that we do all around the world with lots of different projects, and this is a form of digital preservation. So the types of archiving can be thought of as like hot, warm, and cold. So for example, hot can be a frequently accessed digital library. It's something perhaps that lives on the internet that you can access all the time. But like items are continually being sort of added to it. So that would be an example of hot archiving. There's warm archiving, which is the Internet Archive. It's described as a warm archive, and we have the Wayback Machine search layer on top of it. So if you've never checked out archive.org and the Wayback Machine, it's amazing. You can, they basically take snapshots of websites, and I don't mean image snapshots, but actual like file snapshots of websites. And you can search for a domain and like go and visit a website as it looked in a certain year and month, depending on like how often they actually archive that site. I think it's actually really cool. So a lot of you will have already like seen that before and kind of laughed at maybe original websites you've created. And it can be really interesting for things like just looking at media and newspaper websites and things like that too. Then we have something like code archiving, which can actually be code in a literal sense. So two examples of literally code archiving is the Arctic World Archive and also the Arctic Code Vault, which GitHub set up recently. So if you go to archiveprogram.github.com, they explain what it is. And it's actually really cool. So if you have contributed to any of these projects, and there's a huge list of them, by the way, then your commits and your actual code might have been archived in this process. So it's a pretty cool idea. I'm hoping that some people are dropping these links in the chat. I'm sorry that I didn't actually think of doing that, because I could have with my Stream Deck, which I use on my normal stream to do. But so this is actually just the archive program that GitHub started specifically is trying to preserve basically like how code was for us right now for future generations. So anyone who sort of codes feels probably slightly apprehensive about this, because it's just like, oh my God, but every like year that I look back on my old code, I'm just like wanting to scream at how bad it is. Some of my code is actually now stuck in the Arctic, and someone's going to look at it later and laugh at it. So it's an interesting thing to have. So anyway, that's that. So I think that's actually pretty cool. And so here's an example, though, like a very simple example of a preservation of a website specifically, which is a digital asset. I created this website in 1989 when I was first like learning how to do web pages. Like I basically went from basic on the Commodore 64 to macros and VB on Excel, and then I moved to websites. And so I found this on a floppy disk 18 years later, like in 2017. I was able to buy a USB floppy disk drive. I read the disk once and like immediately copied stuff off it, and then the disk actually stopped working. So I'm so glad I did that. That shows physical deterioration, right? So I was doing digital preservation of the floppy drive contents, and then I went and put the first website I ever made on the internet. So anyone can just go and see this on PokemonCheck.glitch.me. I think my iPad is going to do that really fancy iCloud thing and let me paste that in. It is awesome. Thanks, Apple. That's actually really cool. So this
actually is pretty good time.
Yeah. It's actually what? Sorry, the copy paste.
No, I think Paul was. Sorry, I think Paul was saying this. The site is good for the like really nice site for the era that it was created in. That's what he was saying.
I appreciate that.
Totally agree.
It even has my old email address, which I don't have anymore.
How old were you? Roughly, how old were you when you made this?
And then I had like a CGI, like counter, which obviously doesn't work anymore, but that was extremedm.com, which is great. So so that's an example, but that's an example of digital preservation, right? It's just like taking something that was stuck on a floppy drive that didn't exist anywhere else, and then I happened to come across it and then made the effort to go and read the data off, and now it's actually like living online. So that's pretty cool. So if you do have old stuff like that, I would encourage you to put it on the internet, because this wasn't in the Wayback Machine, which made me really sad. So now, like, it's up there, and it hopefully will get scooped up by the Internet Archive, not the Wayback Machine. But yeah, that's an example of something that you can do now with digital preservation if you want to. All right, so I'm taking way too long to get through this, so I'm going to start speeding up a little bit. Another note that I wanted to call out, which actually was very surprising for me at the time when it happened, is an example of migration for digital preservation. So this is an application specifically, which is why I think it's really interesting. It's relevant to our topic today. Adobe Flash is a great example of digital preservation, even if it wasn't done for altruistic reasons, which I don't think it was. So the old way of using Adobe Flash was you published to these self-contained shockwave files that the browsers needed a plugin to play, right? So they needed to know how to, look at these packages and play it. And when the iPhone came out, it didn't support Flash, and that caused like this huge sort of rift in the web publishing community, because all of these websites just stopped working, and most of them were things like flashy restaurant websites where you just want to view the menu, and it was a very frustrating experience. So what's interesting is that Adobe Flash pivoted to basically allowing you to publish to HTML, CSS, and JavaScript for native web instead. So they use things like SVG, and when this first came out, they were actually using the library create.js. I don't know if they still use that, but that was what they were using, which comes with things like easel.js and all of these other really cool stuff that basically does stuff with both Canvas and SVG. So I think that's really impressive. So I was trying to port some of my projects, but some of mine had scripts inside of movie clips, which unfortunately aren't supported with the new versions of Flash. So I was unable to port it. But some of the older ones that aren't doing stupid cheaty things like what I used to do in Flash are actually able to be ported. So I think that's really cool, because authors win, users win. It improves accessibility and security, because Flash had issues with both of those. So that is another example of digital preservation. All right, so
could I ask a question?
Yeah.
So that's super interesting. I didn't realize that. Like, it's so interesting to hear that Adobe's now like with the same program letting you save it, and then it produces HTML and CSS and JavaScript. I did not know that. Does it let you like open up an existing .swf file and then export it as web native code, or is that not possible?
Not that I know of, but if you can manage to get a Swift decompiler working on your machine, you can decompile it back into an FLA file, which is the I guess the working file version, the non-published version of the file. Does that make
Okay.
sense? And then
Yeah.
probably could do it from there. I used Flash decompilers all the time because I was always like, "Ooh, how did they do that cool effect?" You know, and so it's similar to view source. You just had an extra step in order to have to do it, right? So, so technically the answer is yes, but you might actually need to then find a digitally preserved version of a Swift decompiler, which is like a very old concept. So there's multiple layers to that digital preservation right there. That's a great question because I think that's quite funny how that came out.
Yeah, well, I mean, this sounds like the porting, like this is out of the things you said, this is porting because you're taking like the thing and you're trying to like get back to the source, and then you're trying to basically run it on another platform. What about emulation for Swifts? The reason I'm sorry, I'm just so interested in Swifts because I used to run like a Flash game and animations site when I was like 12 or 13 or whatever, and so I had all these like. And I don't want all those Flash animations. I know people have uploaded them to YouTube and stuff, but some of them are interactive and you can't really replicate it on YouTube. So I kind of like don't want that stuff to go away.
I think you should give it a try. If you still have them, I would, even if you create a VM with a really old version of Windows, you could probably get a Swift decompiler installed on it. And then you can like move that file into a modern computer environment and then open it with Flash. I guess that's what I would.
Okay.
So like
really
emulation
cool.
technically would save the day by form of VM, I guess. So yeah, it's interesting. Okay, so what about applications and software packages? We sort of skewed that way a little bit with Flash, but I'm interested in the digital preservation of hardware tooling. So we're going to do a really whirlwind tour through which chips I'm specifically interested in. And they are the Atmel AVR series of microchips. And so Atmel is the company, AVR is the architecture invention that this chip series used in order to be produced and run. So it's a microcontroller architecture coined in 1996. It's Harvard architecture-ish. It's actually very close to that, except you can kind of cheat and you can write. You can store data in the program memory, and then you can read back. You can read back from that program memory in real time from the actual program running itself. So that's a slight difference between normal Harvard architecture and like Harvard architecture-ish. It's actually something that I've exploited a lot on these chips. It's incredibly useful if you don't worry about SDRAMs too much.
Maybe you should explain what Harvard architecture is for people.
That's a great question. So Harvard architecture, I'm going to Google it just so we find a picture. It's the concept of separating certain concerns in, I guess, like computers, machines. And so you end up separating the actual, you can have like separate memory space, and then you have another memory space that is used for actually running the program itself. And so I'm on the spot, and so I'm not. I'm like never good at explaining the difference between von Neumann and Harvard architecture. But if you look at the differences, the Harvard model is just split up more into separate pieces, if I understand correctly.
Yeah, it's just there's two different address spaces. It's like there's two different address 1000s. There's data pointers and instruction pointers that are not at all the same. So it's sort of nice in that you don't have problems like buffer overflows starting to execute your stack type of stuff. So it's nice in some ways, but awkward in other ways.
Yes, you still have other stuff that you kind of have to overcome as a result of that, right? It's always trade-offs when it comes to that kind of architecture. That's me saying I'm overtime, so we're just going to keep plowing through. Sorry for us. So these chips have a physical I/O, just meaning that you can plug sensors into physical pins on the chip. It has program memory, so it can run a program, obviously, and it has EEPROM, which is electrically erasable, programmable, read-only memory. So you can write to it, which is kind of misleading when it says read-only, but that's just how it is. It can run it up to 20 megahertz, or some can even run up to 32 megahertz. So what that means is at peak, they can run up to 1 million instructions per second. Sorry, that should have said MIPS, not MPS. But it depends. If it's loading or storing, if it's storing something in memory or loading from memory, it actually takes 2 cycles to do that. But everything else, like arithmetic calculations and things, take 1 cycle, right? And then you can get low-powered options for lower clock speed. So we're talking like a pretty low-powered device. They're used in the automotive industry for things like security, safety, powertrain control, and also entertainment. So currently, BMW, Chrysler, and TRW still use Atmel chips, which is cool. You probably know Atmel chips the best if you've by having played with an Arduino microcontroller, if you've ever played with one. But they're also present in Microsoft Xbox controllers, which I'm not sure many people know about. And it's usually related to the USB connection for the Xbox controllers. So I thought that was pretty cool to learn as well. So you have all of these different hardware options in order to kind of like compile some code for these devices and then run it on them. Because when you look at a bare microchip, right? Shouldn't have written bare microchip, but I was just speaking aloud. They don't have like, you know, they don't have like a network cable or anything like that, right? They just have these kind of, you know, arbitrary pins. And so in order to program them, you kind of have to have like another piece of hardware, and then you can put the chip on it, and then you can basically use the computer to interface with that, right? So, you know, I have some of these, and these are examples of them. I don't have time to cover them, but you can also Google their names. So the AVR ISP Mark II is one of my favorites. The reason why I bring it up is because it's actually discontinued. So it's obsolete, and this is it here. It's in the kind of blue box, and you can see here that we have this little jerry-rigged programming, you know, little shortcut shield socket that people can kind of put on any breadboard in order to kind of have the same interface, which is kind of cool. And this is an example of what an Atmel chip can actually look like as well. So as you can see, you kind of need this extra thing, this extra doodad, in order to program it. And so we're seeing obsolescence even in just like the hardware to program these chips, because this has been discontinued, and that makes me really sad because I love that one. I don't have time to cover this, but then we actually have to have software interfaces that can talk to those hardware programmers, right? So AVR Studio is officially from Atmel. Platform.io is an open source CLI and IDE for programming them, which is actually like really nice and very user-friendly for the maker community. We have AVR Dude, which is a command line app that is cross-platform, and it allows you to upload basically to most Atmel chips with most Atmel compatible programmers. And by programmers, again, I just mean the separate device thing that you need in order to flip the pins in order to, you know, like upload the code. There's also AVR Girl, which is relevant for the rest of our talk, because this is a repo that I put together, which basically more or less does the same thing as what AVR Dude does, but it does it within JavaScript. So you can run it as a command line app, but it's like installed with NPM, and you can also run it just as a library. So AVR Dude can't do that because it's not a library. So that was kind of the main differentiator. There's also smaller, more niche packages such as AVR Fuses. I just want to call out how amazing AVR Fuses logo is. Absolutely incredible. And this is basically just a UI wrapper over AVR Dude. So you can actually just use menu options instead of having to type out, like if you've ever seen AVR Dude's command line interface, it's just a lot of cryptic arguments and flags, and if you get it wrong, you've bricked your chip for life. You know, in a lot of cases, unless you have another different programmer that can rescue it. So it can get kind of hairy, and so it allows you to be able to set separate, you know, preference registers, and it will calculate all of the fuse values for you so that it writes the correct byte to the register so you don't brick your chip. Again, I don't have a lot of time to cover what exactly this stuff is, but it's essentially like, you being able to flip certain options on the chip so that it runs in the specific way you want it to run, and can have write protection and things like that. So it's able to just compute all of that based on what you choose. You can also upload files directly to the device using this, and you basically have to just tell it which programmer you have and which chip you're actually trying to upload to, right? So I love this program because it is just like such a great wrapper for AVR Dude, and it's a wonderful GUI. So that's another example of how we can get there. So how come I actually have a concern about this ecosystem in the first place? Well, first of all, Microchip bought Atmel a few years ago. They produce a competitor chip series called PIC. Very similar in some ways, a little bit different in others. I'm not overly confident if they'll keep both ranges of chips in the long future. It's also just good to get ahead of digital preservation instead of waiting for problems to happen as well. And I just love the history of Atmel's AVR series, and I want to be able to keep our ability to be able to program these chips and play with them in the future, right? And also resurrect old devices that are actually using them. So again, Atmel Studio only runs on Windows. I think that's always been a huge problem. Platform IO is not dedicated to Atmel chips. It supports like a lot of different boards, like, you know, ESP8266, if you're familiar with that, and all sorts of other STM32 chips as well, which are kind of a lot more modern than the AVR chips. So I have a fair amount of confidence in Platform IO because it is amazing, but they're not really dedicated to the cause of Atmel specifically. AVR Dude is not a library, and it also has a GPL2 license, so it's really hard to package it with other things that you're using it with. Hence, you know, AVR fuses chips without AVR Dude, and then you have to tell it where it lives on your hard drive. You know, it's complicated. Again, like, I don't necessarily have an opinion on the licensing stuff. I'm just calling out that it's difficult. And AVR Girl is just like, it requires a lot of maintenance, mostly because I always run into cross-platform bugs. I have all of these different machines at home that I have to try and test the library on manually. It's a real toil for me because I have a full-time job and I've been maintaining this library for like 5 years, and it just slowly kind of starts rotting in places because hardware interfaces like USB and things like that just like subtly change, and security things come in and like all sorts of stuff, right? So it's stressful for me. And then AVR Fuses only runs on Mac OS, and it's one of my favorite programs, not just because the logo is awesome. And so it only runs on Mac OS, but it's really helpful and useful. And so it sucks that it only runs on that, right? So I have all these kind of like slight little digital preservation niggles about all of these tools. So I've been on a really slow mission to port all AVR Girl code to be functionally equivalent in a browser environment. If you've seen any of my other talks, you've kind of seen that. If you've joined my stream on Sundays, you've seen that. The strengths of porting to the browser is that it's cross-platform, just out of the box. There's a smooth papering over of things like USB and serial interfaces, which are actually available as APIs in some browsers these days. You don't need to install separate drivers. You have better security permissions, arguably, than on some operating systems. You don't have to install all of these bespoke, artisanal, fragile applications on your hard drive. So you can just use a PWA, which is super nice. And Arduino and BitBlock are both companies that are actually already totally doing this. So they both have IDEs that run in the browser that you can upload code to the Atmel chips, all in the browser, which is awesome. Both of them do use AVR Girl. So my mission was like slightly accomplished there by having actually people use that technology, which is great. The only caveat is it's only available in Chrome and Chromium-based browsers. So yes, that does mean Microsoft Edge, you know, the successor to Internet Explorer, does actually work with it now. So that did increase the market share a little bit for WebUSB and WebSerial, but it's still complicated, right? It's not quite there yet. So what I wanted to do this week was I was going to take a JavaScript fuse calculator and just like, you know, some HTML code, sprinkle it with a little bit of JavaScript and AVR Girl. And I was going to port AVR fuses into the browser so that it works in every operating system, and the spirit of it is kind of preserved in another format so that hopefully we don't lose it in the future. Got a little distracted and stressed out this week and just ate a lot of ice cream and stayed up way too late most nights for obvious reasons, if you haven't seen line 9 of this buffer yet. But yeah, so I apologize for that. But I do have like a quick demo to show you after this. And then we can hopefully have time for questions. But another cool thing that is happening just before we wrap up is that end-to-end programming of app-mail chips is also happening in the browser. So it's not just the uploading part. We also have BitBlock, who is a contender in the open source hardware community. They've successfully ported AVR GCC functionality to WebAssembly so that you can write your C/C++ program in the browser, like, let's say with like CodeMirror or something like that, or Monaco, which are browser-based code editors. And it will compile it via WASM, which has a compiler inside of it. And then it can pass that compilation payload to AVR Girl, and then she will upload that data to the actual chip. All in the browser, no sneaky servers, cloud servers compiling for you, no sneaky, like process running on your machine that the browser's talking to via like a server. It's all just like native in the browser now, which is kind of incredible. So if you want to check out that repo, it is at that address there. But like, let's look at a quick demo of what this can look like. I actually already have this with the dev tools up. So I just have an Arduino here. So for us, it's probably going to swap to my camera here. So I just have an Arduino here, and I want to upload some code to this that makes the light blink, right? And so this web page that I have here, if we go back to it, allows you to pick the board. I've just put a few board options in here. So this is an Arduino Uno. I am going to select my blink file in order to upload it. I'm then going to click upload, and this is where we have the permission interface. I'm going to find the actual Arduino device. I know that this kind of like discovery name is not the best right now. This is what we sort of have to work with. I'm going to connect to that, which I've already paired with. And then when I hold up the device, you'll actually see it sort of blink a couple of times. It doesn't really show much when it's uploading, but I just want you to know that it's actually doing the thing. And so in the dev tools, you saw that that was really quick. So let's upload just like a slightly larger file. Standard formatter is 34 kilobytes, huge for a microcontroller. And then if we upload it again, that's going to take a little bit longer. So you can actually kind of see that there's some, progress going on. And then that was it. So if you combine that with, BitBlock's WASM AVR GCC compiler, that's just kind of awesome that we've now kind of found another platform that does all the pieces for us. That is just cross-platform out of the box. And I think that's actually really promising. So the question here really is, should we use browsers as a digital preservation platform, or should we be doing this with hardware in the browsers? I don't know, but I just think there's a lot of potential here. This is the mad science experimentation part of it, right? Like, it's not necessarily, the answer, but it's something that I'm playing with a lot. And I really love the idea of browsers being able to be a digital preservation platform beyond just a bunch of web pages, right? Or searchable archives of images. I think it could be much more than that. But also, I'm tired of all the miscellaneous and niche hardware tools sitting around on my computer, breaking so gently and slowly with every operating system release. And so I'm sort of looking for other options. And that's all. So thanks for having me. Sorry that I went overtime, but hopefully we can still have a good discussion online.
That's amazing. Thank you, Suz. That's what an amazing talk. I think we have some questions in the chat, so I'm really excited to let those people get a chance to ask their questions. We'll just actually have to read them out. So I saw some questions about, and I'm actually also really curious about this. Can the web USB API talk to any USB device at all, or does that have to sort of opt in with a special identifier in the name of the device?
That's such a good question. Thank you for asking that. Yeah, so theoretically, any existing device that existed before Web USB can theoretically still work. There's an extra little option in the Web USB specification. It's an extra descriptor that you can actually program into your device, and it's a URL. So when you plug it in, it'll be a suggested URL that you can basically click the little notification and Chrome will take you straight to the manufacturer recommended website. So I think that's great for security and things like that. But even if you don't have that descriptor, you can still use it with anything. So I've used WebUSB with things like thermal printers to recreate like the Game Boy camera, for example, which is another idea of like digital preservation, right?
Wait, could you explain about that? That sounded really cool.
I feel like I'm going to go on a tangent, but it's just like I used, I guess, like the webcam in a browser, and then I used just like a library to kind of like use the same dithering technique as a Game Boy camera, and then you can send it to a thermal printer, which will kind of like print it with the little Game Boy frame and all that around it. So
that's super cool.
it's on my GitHub. If you search for Game Boy on my GitHub, you should find the. Yeah.
Amazing. Cool. Yeah, I'll go ahead and also show a little link to your GitHub over the video in a second. Paul, John, what do you guys think? Do you have any questions or anything in the chat that stood out to you?
Yeah. Well, go ahead, Paul.
I was going to say there was a question about whether or not real-time timing is effective, which becomes a question with performance. So if you're having to send precisely timed signals over the serial or USB, does the browser environment perform well enough for that particular need?
Yeah, so that's a hard problem. It's usually not a question of performance. I haven't run into that. I've even done dirty stuff like run while loops to read back off the device, which will lock up the CPU to a degree. Instead of actually building proper, like message queues and things like that. But it's more a problem of like, is set timeout going to be accurate enough, for example, and things like that. Generally, timeouts for these devices are pretty generous. So for example, a lot of Atmel chips are 400 milliseconds. So you can pretty much trust that that's going to happen within that time, and it's not necessarily requiring it to be exactly 400. So, but yeah, that's a really good question. That would apply to a lot of other hardware devices, but not to Atmel chips.
This looks really great. I'm in some ways, unfortunately, been using PICs much more than AVR, and the whole PIC world is in some ways much less open. But I was wondering if there's any sort like browser-based PIC or similarly easy to use PIC tools these days, because I've been kind of out of this world recently.
Yes. So I don't know the answer to that question. I do know that, is this true that most of the time PIC microcontrollers need like the high voltage programmers to upload code to them, or because that tends to be a little bit more difficult too?
Not necessarily anymore.
Okay.
I think you need like initially to program a fuse to enable low voltage programming, but once that's done, you don't anymore.
Okay. The last time I used a PIC chip, I was actually trying to read the data back off it, but it wasn't my chip, so I was being a bit naughty. So like I was running into the high voltage thing. But yeah, I don't actually know very much at all about the PIC micros, the ecosystem. So I'm excited to see if you find anything out.
I'll take a look. One other quick comment is, I don't know, I think many people may not know that the Internet Archive has a lot of stuff that's not just web archives. Like you can find all sorts of old DOS games and apps that run in, it's essentially DOSBox in the browser. You can even upload like floppy images. They also have, at the archive headquarters, a whole collection of like old video and audio equipment to archive random formats that are hard to read these days. So they do a lot more than just the web. So
yeah, totally. I think we know them for the Wayback Machine, which is really just one search engine for one part of what they archive, which is actually a really good call out.
Yeah.
Also, just really quickly, Monteslu in the chat just wrote something really nice. Monteslu, you saved my bacon because last night the set signals spec incompatibility thing happened with AVR Girl, and that's also why I noticed your pull request to that. So thank you. You just saved the demo for today. So I just wanted to give them a quick shout out. Cool.
They were also asking if there were any general areas of help needed on AVR Girl. I also was curious about that because I know how much work it can be to maintain something, and especially the like really esoteric operating systems that people use. It's like the bane of my existence working on WebTorrent desktop is like, you know, people will be like, you know, notifications don't work on this like weird Linux that's like they're the only person in the world because who uses it because they compiled it from scratch, you know, and they're using their own like notification system, and it's like, okay, you know, now I have to like run this in a VM and like try to figure out what the problem is, and it's like it's gonna help like one user or maybe 5 users, and you know, I want to help everybody, but like it's you gotta triage, you know, to some extent. There's just too many things. How do you deal? Like, I mean, I guess, yeah, it's a struggle. I could sense from your voice when you were talking about it that you feel overwhelmed and like maybe even a little guilty about not being able to keep up. At least that's how I feel.
I think what you picked up on was embarrassment. Yeah.
I don't think you should be embarrassed. I think I've been coming around to a more healthy way of thinking about it. But yeah, it's just too many things to do, and you know, you have a full-time job. So, but is there anything, if somebody really wanted to help, something, you know, that they could do that would be approachable? You know, I know it's hard. It's also hard when the project is like relatively low level. It's hard to have people just kind of stumble upon it and then just be helpful if there's so much knowledge, sort of pre-knowledge that you need before you can even dive in. Are there easier tasks that people could do, or is it really just about like you need people who have that expertise to be helpful?
That's an amazing question. I'm going to try and be as quick as possible because I could talk about that for hours. But side note, I started my Twitch stream because I was trying to see if I could get more maintainers by showing how it wasn't a scary library, and that, yeah. So that was literally why my Twitch stream started. You know, almost 5 years ago now. But also, what I need is like people to just test to tell me whether it works on their machine, right? Like that's actually really important to me because it can be very nuanced, as you just said. And so I did have like a hidden thing called test pilot in there. So if you type AVR Girl test pilot in the command line tool, it pops up a browser and authenticates you with GitHub, and then you can like run diagnostics. But you have to have the boards. You know, you have to have an Arduino Uno or something to help me out. So that's a problem. What you can help me with is things like, you know, possibly dependencies if they're out of date, because, you know, like it's just, there's more important things to do for me sometimes. The other thing that I really want, and I started doing on my stream a few months ago before I got sick actually, was writing a deserializer so that when I'm debugging issues and the opcodes are coming from the actual chip, just translating that into like English, you know, of what each byte opcode means. And I actually have a reference to that in the library itself. So you don't even need to know what those opcodes are. You can just open the constants file and they're all listed there in English. And I just want to be able to like deserialize that into like English so I can actually see, because otherwise I'm looking at each opcode one at a time and mentally translating it in my head. And it's really slow debugging when there's like a weird issue where stuff's happening out of order. So I would love help with that, because as much as that's a really exciting passing problem to me, I just haven't been able to set aside the time for it. So it's like kind of like miscellaneous things like that don't necessarily have to be about knowing the chip itself that people can help with.
Right. I'll put up a link to AVR Girl on GitHub on the video. So hopefully you get more good pull requests than like issues with help it doesn't work. But
yeah, if you look in there right now, there's a lot of help it doesn't work, and then me saying I can't reproduce. So it's good time.
Cool. Did anyone else have any other thoughts or see anything in the questions or anything you wanted to chat about?
It was hard for me to keep up. I'm just wondering if anyone else has anything. I saw a few cool chat things, but
I guess I'll say that I think that the idea of preserving stuff by, you know, making it more web friendly is a really cool idea. I think that the web has had a lot of longevity as a platform, much more so than a lot of like almost anything else, and like the concerns about backwards compatibility are, you know, obviously way more taken way more seriously, though not perfect, I have to say, especially with all the the changes that people have been making with auto playing audio recently that broke so many amazing demos. And you know, but in general, I think it's pretty good. And so, yeah, I really like, yeah, I just really like the general thrust of
yeah, I think you took the words right out of my mouth. That the whole like fiercely backwards compatible thing is definitely what made me go, ooh, you know, we could exploit this to a certain degree. I just don't feel like Web Serial and Web USB are like safe yet, you know, because they're still experimental. So like, I think that's the biggest weakness with this approach right now, at least for hardware tooling. But the fact that WASM is like really popular and now we're like literally compiling compilers for WASM, I think that that's actually really promising, right? So like that was the missing piece where we can say, okay, we can do this end to end now. So why aren't we not supporting this as non-experimental? So.
There's also just so much more trust in, like, I mean, if I use a web page, you know, and I see this prompt, like, and I'm just giving it access to this one device, I feel so much better about it than like if I'm installing an entire GUI program from, you know, from some website and the app hasn't been updated in 2 years or 3 years, and I'm just like, I don't know what this is doing and if it's secure, you know. And that's why the pushback against stuff like these lower level hardware APIs from some people doesn't make much sense to me. There's the sort of mistaken idea, I think, that like the web should just be a document viewer, and you know, that somehow native apps are better suited for these things. But you know, if I'm doing something that you know, doing something like updating the firmware on my headphones, you know, I don't want to install like some random binary from Bose and like have it run in my menu bar for like the one time a year that like I update it or something. You know what I mean?
Oh my God,
I just want to go to the website and then say like, here's my headphones, like do the thing, and then I close the tab. It's like obviously much safer. So anyway, I don't know. I think the concern is maybe more around like a random website asking for permission and then people accidentally granting it and not understanding and stuff like that. But,
yeah, because we haven't done a good job with educating web users, and they are broad based, right, of people who aren't programmers. You know, there's more non-programmers on the web than there are programmers, so that's our cross to bear for sure. But yeah, I totally agree with absolutely everything you just said as well. So.
I mean, there's really two things that y'all are highlighting here. One of them is the potential for the security upside of using the web for this sort of thing. The other is just having a single layer, which is the web API and the WebAssembly, and now you're having portability across all of your deployment platforms.
Right. Yeah, there's just a lot of wins from it. It's just the paradigm shift is a difficult one for some people, and I do think that there's valid arguments on both sides as well. So,
yeah, the fingerprintability stuff and Safari and all that. Yeah. Totally,
yeah. So Tiny Fluff actually brings up a good point. Like, so for example, in the mechanical keyboard community, theoretically, you could have someone say, "Oh, you know, I have this cool firmware build that I made for this keyboard. Just plug it in, and then it actually just secretly installs a keylogger, right?" And so nothing is stopping that from happening currently, right? Someone can have a custom build of like, what is it called? What's that one that starts with Q? I'm just blanking on it, but like there's a really popular mechanical keyboard software package starts with Q. Someone could do their own custom build of it, and then it does have a keylogger in it. That's a reality now, but I understand that like it feels like there's less barrier to that happening because the web makes it so easy, I guess.
Right. Yeah, I mean, this is a little bit of a tangent, but I'm coming to think more and more that we need to have like two stages before these more intense APIs, like you know, so a native app, the barrier to like being able to do this kind of stuff is you install the app, and then at that point it can just do whatever it wants. It has basically, I mean, it can do whatever you can do to your computer, with occasional prompts and stuff that they're sort of trying to add in now. But in general, it can do whatever it wants. With the web, we have this permission prompt, but because it's coming from just like a web page, and people might not really understand kind of like what it's saying. But if you had to like install the web app, like you do with the PWA, you know, and then you got asked, then it just seems like now it's sort of the same as a native app, and no one's saying that we should take away these abilities from native apps. So that might be kind of the happy medium. But anyway, sorry, I'm just indulging myself in my own
No, it's a really good point.
opinion about what to do.
Because, you know, iOS
think that would be
devices
great.
used to give enormous privileges, and that's why people wanted to make apps instead of web pages, because they can get so much more data from the user. And then now that we have good security practices, or better ones around things, like iOS is a shining example of progress in that. Yeah, I totally get what you're saying. And I think it's something that we should hopefully embrace more.
Mm-hmm.
But still, I think this is like being able to do this program hardware in the browser is a huge step forward from like the last time I was trying to do some AVR stuff where I opened up my Windows VM, installed AVR Studio. That's not a good experience.
Yeah, and it's designed for like electrical engineers, you know, chained to their desk writing massive programs, and it's not really designed for like us either. And so, you know, it's like the Visual Studio on steroids for like electrical engineers. So
Cool. Does anyone else have any final thoughts? Oh, I'm getting a question from Mick. So for those of you who are just watching the stream for the first time, Mick Nicola is one of our regular panelists, but he had to bounce at the beginning because his kid just walked his first steps. So yeah, this is pretty wild. He literally bounced right before the stream started. So congrats to him. And now he's complaining in the chat that we're embarrassing him. But anyway, he had a question. Can you get AVR or PIC to pay you for this work? I don't know if you can answer that, or you have thoughts on that.
Because I'm currently sponsored on a work visa, and that greatly restricts what I can do. I can basically work my full-time job and that's it. So if I went back home to Australia, my options would open up a lot more, but I'm just going to be super real with this, especially given that the election is affecting me in this specific way as well. That's not something that I could do. It doesn't mean that we can't support someone else to help me out with it. It's just that I can't be part of that effort. So that does make things more difficult too. I haven't ever been able to pursue something like that because of that reason. So I've got to keep my job.
Too bad.
Yeah. Well, yeah. Maybe our laws will get more sane at some point. Cool. Well, it's been great, guys. I thank you so much, Suz, for coming. I really enjoyed your talk and the enthusiasm you bring to teaching, and I can see it's getting dark where you are. So sorry for keeping you so long. Thanks for joining, Paul, John. The great questions in the chat. We'll be back again next week for another Speakeasy JS. So we do them every Friday at 4 p.m. at the same exact time. Next week, we have David Gutman speaking about how to build a WebRTC app in under 6 years, which is a hilarious talk title.
I'm so excited for that. I'm totally there.
Yeah, and actually for that edition of the talk, we're going to be using a different social platform at the end of the talk part, and it's actually what his talk is going to be about, which is this really cool app he's made called Rambly. So I'm looking forward to playing around with that with everybody at the end and just hearing how it was built. So it should be really cool. And Suz, do you have anything final to say to everybody before we head into the social part of the event? I'll just give you the last word if you want.
Everyone like hanging out for so long and just kind of like humoring me about a very niche passion of mine. So I really appreciate it. And again, for us, it's been so nice to have an excuse just to catch up too, because I think that we have so many similar ideas and things, and it's just a real privilege to be able to come on and talk about some of mine. So thank you. Totally, yeah. Thanks so much for coming. Cool. So now I'm just going to give a quick little explainer for what the next part of the event is. So